All right, we've been solving systems of equations, and we've done so by graphing and done by tables and also by substitution. And so today we're going to look at solving systems of equation by, we got to do something about this. Elimination. We're going to solve by elimination. I'm going to have to do this on every slide because that's going to really bother me. Okay, so I got two linear equations here. I got 4x minus 3y equals minus 22, and my second one is 2x plus 3y equals 16. Now, in using the method of elimination, I can add sometimes. Other times I can subtract the two equations. Other times I have to multiply one of the equations so that I can add or subtract. But in this particular one, I can see right here that with this minus 3y and this plus 3y, if I just simply add these two equations together, I'm going to get rid of the y so that I can then isolate and solve for x. So that's what I'm going to do. I'm going to add these two equations together. So we got 4x plus 2x equals 6x, and minus 3y plus 3y, of course, is 0. Minus 22 plus 16 is minus 6. I'm going to divide both sides of the equation by x, by 6, isolating the x. And so x is now equal to minus 1. So now I'm going to take this minus 1 for x and substitute it in one of these equations. I could choose either one. My choice, however, is this second equation, 2x plus 3y equals 16, because the numbers are smaller and just seems like it might be easier. So here I have substituted in the minus 1 for x. So I've got 2 times minus 1 equals minus 2 plus 3y equals 16. I'm going to add 2 to both sides, and so now I've got 3y equals 18. I'm going to divide both sides by y, and y is now equal to 6, and my possible solution set is minus 1 and 6. Now, as always, I'm going to check my work. And in doing so, I'm going to use this equation right here. I'm going to substitute in the minus 1 and the 6 for x and y. And so now I've got 4 times minus 1 minus 3 times 6 equals minus 22. 4 times minus 1 is minus 4. 3 times 6 is minus 3 times 6 is minus 18 equals 22. And minus 22 is, in fact, equal to minus 22. This is a good solution set, solving by elimination. Okay, so as we said before, we're going to solve by elimination. And when we solve by elimination, we sometimes are going to add the two equations together. Other times we're going to subtract them. Sometimes we may have to multiply one of the equations so we can add or subtract them. So I've got two linear equations here. I've got 6x minus 5y equals minus 8. And I've got 4x minus 5y equals minus 12. And I'm looking here and I say, if I just subtract these two equations, I'm going to eliminate the y variable. And so that's what we're going to do. So I've got 6x minus 4x gives me 2x. Minus 5y minus 5y. Minus 5y is positive 5y. So I've got a minus 5y plus 5y equals 0. And I've got minus 8 plus 12, minus 12, which is plus 12, is going to give me 4. We're going to divide both sides by 2, and x is equal to 2. Now I'm going to take one of these equations, and I'm going to plug in 2 for the x value. And I'm going to choose this one. It looks like maybe it might be a little bit easier. So we're going to try it. Doesn't really matter. I could use either equation. So I got 6 times 2 is 12. 12 minus 5y is minus 8. I'm going to subtract 12 from both sides, so I got minus 5y minus 20, and y is equal to not negative 4, it's going to be plus 4. Dividing a negative into a negative gives me plus 4. And so my possible solution set is 2x plus 4. Now, I certainly better check my work because I've already made a mistake in here, so I'm going to plug it in, and I'm going to plug in the 2 for x and the 4 for y. So I got 4 times 2 is 8. I got minus 5 times positive 4 is minus 20 equals minus 12. And minus 12 does in fact equal minus 12. Easy to make mistakes. Got to watch your signs. A lot of maneuvering back and forth. And this is why you definitely want to check your work. 9 times out of 10, you've done one or two things wrong. You've either written down the equations incorrectly or you've got a sign error like I just did. Check your work. Okay, we're continuing to work systems of equation by elimination. And we have looked at where we add and subtract. And now we're going to take one where we're going to have to multiply in order to either add or subtract to clear out one of the variables. And so we need to fix this. Anyway, I've got two linear equations here. I've got minus 6w minus 8z equals minus 44, and 3w plus 6z equals 36. Now, in looking at these two equations, I see if I could multiply this 3w by 2, then I'd have a minus 6w and a 6w after multiplying by 2, and I could clear it out. However, I can't just multiply 2 times 3w. I got to multiply 2 by the entire thing. So that's what I'm going to do. So I got 2 times 3w is 6w, 2 times minus 6z is 12z, and 2 times 36 is 72. And now I'm going to bring this equation here, this first equation in here, and subtract it. Really, I'm going to add it to the equation that I put together after multiplying by 2. So I've got 6w minus 6w is 0, 12z minus 8z is 4z, and 72 minus 44 is 28. I'm going to divide 4 to both sides, and z is equal to 7. So I'm going to take this 7 and I'm going to plug it into one of the equations. I just chose for no reason really to the first equation. And so I've got minus 6w minus 8 times 7, substituting in the 7 for the z, equals minus 44. And minus 6w minus 56. Minus 8 times 7 is minus 56 equals minus 44. I add 56 to both sides, and I've got minus 6w equals 12. And divide minus 6 into 12, and it gives me w is equal to minus 2. So I've got minus 2 and 7 as my possible solution. And I'm going to plug it back into one of the equations. As always, I want to check my work, make sure I've got this correct. And I'll drop in the minus 2 for the x in the for the w into 3w plus 6z equals 36, and the 7 in for the z. And so I've got 3 times minus 2 is minus 6, and I've got 6 times 7 is 42, so we got minus 6 plus 42 equals 36, and 36 equals 36. Minus 2, 7 is a valid solution. Okay, let's look at a couple more, and we're going to wrap this all up. Now, I've got two linear equations here, and I've got 2x plus 3y equals 5, and 6x plus 9y equals 15. And so I'm first looking here, and I say, okay, well, if I multiply the first equation by 3, I can at least get, or minus 3. If I divide it by minus 3, I can get a minus 6 and a 6x, cancel the x out. That sounds like a good idea. So that's what I do over here. So I got minus 3 times 2x gives me minus 6x, and minus 3 times minus 3y gives me minus 9y. And finishing it off by multiplying minus 3 times 5 gives me minus 15. So I got 6x minus 9y equals minus 15. I drop in the second equation, and I'm going to add those together. Well, minus 6 plus 6x, minus 6x plus 6x is 0. Minus 9y plus 9y is 0. And minus 15 plus 15 is 0. 0 equals 0. So what am I going to do with this? Well, since 0 equals 0 is a true statement, 0 does equal 0, then these two equations have infinite solutions. And guess what? It's the same line. So it has infinite solutions. It means it's also consistent and dependent. Infinite solutions. All right, last one we're going to look at. Everybody says, all right, last one we're going to look at. All right, got two linear equations here. 5a plus 15b equals minus 24. And minus 2a minus 6b equals 28. Now, this is a little bit trickier one. It's one of the reasons why I picked it. In trying to get these coefficients in here to be something that I can add and subtract and cancel out. Well, in looking at it, if I were to take this first equation and multiply it by 2 over 5, I could at least get to a 2a that I could cancel out against that minus 2a over there in the second equation. So let's do that. So I got 2/5 times 5a. Well, 2/5 times 5a is going to give me 2a. And now 2/5 times 15b. Well, 5 will go into 15 3 times. 3 times 2 is 6. 6b. And then I take 2/5 times minus 24. 2 times minus 24 is minus 48 over 5. 5 will go into 45 9 times, leaves 3 left over. And so then the answer is minus 9.6. So I drop that equation back over here because I am going to add it to this equation. And I got minus 2a plus 2a equals 0. And minus 6b plus 6b is equal to 0. Kind of looking like I might have infinite solutions. However, 28 minus 9.6 is 18.4. Well, 0 does not equal 18.4. Not in any universe. So I have no solution. So we've looked at elimination by adding, elimination by subtracting, having to multiply using elimination. We've seen elimination with infinite solutions, and now we've seen elimination giving us no solution. We've run the gamut on solving systems of equation by elimination.